Good morning to everyone. Today we are going to look at the numerical problems on 1D compressible flow. I myself, Moses Dev Prasanna, Assistant Professor in the Department of Aeronautical Engineering, Hindustan Institute of Technology, will be presenting how to solve problems on 1D compressible flow. Let us take a problem on uh, the topic review of thermodynamic concepts. The question is given here. Air enters the compressor of a stationary gas turbine power plant with a static temperature of 300 Kelvin and an average velocity of 150 meter per second. It is discharged from the compressor with an average velocity of 50 meter per second. The compressor receives 1 lakh joule per kg of work from the turbine, and the heat loss to the surroundings is 10,000 joule per kg. Assuming steady flow, calculate the enthalpy and temperature of the air leaving the compressor, taking into account the variation of the specific heat of the air with temperature. Right. In this question, they have given uh, data of a compressor. Compressor is basically um, open device. That means it can be categorized as a control volume or open system, right? In this problem, they have given the temperature at the inlet and velocity at the inlet as 300 Kelvin and velocity as 150 meter per second. At the exit of the compressor, the velocity is given as 50 meter per second. In addition to this, they have given the work input to the compressor or the shaft work of the compressor per unit mass, which is given as 1 lakh joule per kg. Since this is the work input or work done on the system, I take this work as a negative work. Then the heat lost from the compressor to the surrounding is given as 10,000 joule per kg. Again, the heat is lost from the system to the surroundings. To indicate this loss of heat, I use the negative sign. And the value of the heat loss is 10,000 joule per kg. Now, we are asked to calculate the enthalpy and temperature of the air leaving the compressor. That means H2 and T2. I have shown the simple sketch of a compressor where 1 is the inlet and 2 indicates the exit of the compressor. dW by ds is the input shaft work and dq is the heat lost from the compressor. Actually, in this case, they have given the work transfer and the heat transfer per unit mass basis. Right. How to find out the required values like H2 and T2? We are going to use the approach of applying steady flow energy equation. Assuming the elevation of inlet and exit of the compressor to be same, that means Z1 is equal to Z2, the potential energy term will become 0. Therefore, I can write the steady flow energy equation as dq by dm plus h1 plus v1 squared by 2 is equal to dws by dm plus h2 plus v2 squared by 2. Right, we have to solve this equation. We need to substitute the known values and we have to find out the unknown. Here, the known values are dq by dm, the heat loss, enthalpy, which can be determined from the given temperature T1, V1 squared by 2, velocity is given at the inlet, dWs by dm, the work transfer to the compressor given, V2 squared by 2 is also given, the velocity at the exit of the compressor, and the only unknown term is H2. Right, so first we shall find out the value of H2 using the steady flow energy equation. Before doing that, we need the value of H1. To find out the value of H1, we need to find the value of Cp at the given temperature T1 equal to 300 Kelvin. For that, I use a table called thermodynamic properties of air. Right, so assuming air to be the working fluid, or as given in the question, air enters the compressor. So working fluid is air. So I take the properties, thermodynamic properties of air. In this table, first column gives the temperature in Kelvin, and the second column gives the values of enthalpy in kilojoule per kg. So what I have to do to find out the value of H1, I find the value of T1 in the first column. It is 300 Kelvin. Against that value, what is the value of H? It is 301.329 kilojoule per kg. So H1 is determined from the table as 301.329 kilojoule per kg as given in the table. Since the value of dq by dm and dws by dm are given in terms of joule per kg, I can convert the value of H1 so as I get the unit as joule per kg. So to convert kilojoule to joule, I multiplied by 1000. Finally, I get the value of H1 as 301.329 joule per kg. So now I got the value of H1. Substituting all the values in the equation, all the known values in the equation, and I can find the value of H2. Right. So I find the value of H2 from the steady flow energy equation. Right. We need another term called T2. That is the temperature of the air leaving the compressor. How to find out? So there is a relation between enthalpy and absolute temperature. For a perfect gas, H can be written as Cp into T. Therefore, H2 can be written as Cp into T2. Right. And again, this Cp should be the Cp corresponding to the temperature T2. Okay. So what I can do, once again I go back to the table we already used. We know the value of H2. I can directly get the value of T2 from the table. Right? I'll go back to the previous slide where we have seen the table. So once I know the value of H2, I'll go to the second column in this table. I'll find that value and then I'll see what is the value of T2. For example, if the value of H2 is 356, for example, so this is H2 in case, then I will find out what is the corresponding value of T, that is the value of T2. So in this way, I can find out the value of T2 and H2 for the given question. I hope the problem is clear to everyone. I thank you everyone for watching this video.